Welcome back to the Advanced Microcontroller series. In the previous session we discussed about microcontroller interrupts. But in today's session we will learning about INT interrupt. So how many total external interrupts are there? Only one, that is INT pin or RB0. So here when switch 1 is pressed, RB0 generate the interrupt. So okay, let's do this using the code. So here interrupt source is external interrupt. So when interrupt occur, LED toggle. So okay, let's open the data sheet. So here we having INT interrupt. So external interrupt on the RB0 or INT pin is edge triggered. So what happen in the edge trigger? So what happen in the edge trigger? So when we press the switch, so this is the condition. So when we press the switch, here what happens? This is what? Falling edge, isn't it? So this is what? Falling edge. Here it is falling edge when you press it, when we press the switch. Here switch is pressed. So pull up circuit, we set falling edge. Either rising if bit INT EDG is set. So what here mentioned, rising means INT EDG is set. Falling means INT EDG is clear. So if you are using rising edge, then you should set INT EDG. So we need to write like this. So if you are using rising edge, so if you are using falling edge, then you need to clear the bits like this. In code we using falling edge. Interrupt request recorded in flag bit. So flag is, here you can see interrupt request recorded in flag bit. So flag is 1. So when a valid edge appears on the RB0 or INT pin flag bit, INTF is set. So flag is INTF equals to 1. So external interrupt flag is set. 1 means enable. The interrupt can be disabled by clearing the bit. 0 means disable. So INTF equals to 1 means enabling external interrupt. So if it is 0 means what? Disabling external interrupt. So here I am not writing GIE, so it is common for all. Okay, let's write the code. So main.c, while of 1 so here you can see here nothing is there. So where our logic? When I press RB0, external interrupt generated. So where will control go? It will go to the ISR. So here you can see INTF equals to 1. So we need to clear this before re-enable. So okay, let's go to the MPLAB IDE file, open project. Here interrupt sources, external interrupt. So open the code. So this is the code. Here you can see we are using 2 LEDs. Sorry, here you can see LED array 1 equals to 0x00. Why? Because it is output device. And GIE is equals to 1. So here you can see nothing is there, right? And here we having external interrupt dot C. So here we having only one LED, not 2 LED. By mistake I said sorry. And ISR dot C. So here you can see INTF equals to 1. Then LED 1 toggles. Here you can see we are using port D. The same thing. Okay. Click build. The project external interrupt. You need to add file. Okay, so I'm reopen this. File, here open project. Here I am going to select external interrupt. Now click build. Yeah, build is successful. Go to the PICSimLab Simulator. So before that, so here you can see so here we having some warning, right? Function ISR is never called. Why this shows? Because compiler is not understand this logic. So okay, go to the compiler guide, X8 compiler guide. So here Control F interrupt, search for interrupt 5.9, right? Keep go. Sorry. control as interrupt. So I'm directly searching ISR instead of interrupt. See here interrupt, yeah, here I got interrupts. See here writing an interrupt service routine means ISR. Write each ISR prototype using either interrupt or interrupt specifier. Just copy this and paste it here. So now build, check any warnings, no, right? Now go to the PICSimLab Simulator. Now here click node external interrupt. So when you press the RB0, the LED should turn on, and when you press again, LED should turn off. See, again press LED on, then press LED off. Sorry. One second. I'm just rebuild it. Yeah. See, LED turns on, LED turns off. Again see, LED turns on, again LED turns off. Press, then on, again press off. This is what logic. When you press, LED turns on, and when you press again, LED turns off. So here you can see in the code enable all global interrupts. So here disable it, then click build, then go to the PICSimLab Simulator, then click file, reload last. Now press no output, right? So not work, LED not on. So whenever interrupt occur, control goes to the interrupt handler. After that it comes back where they get interrupted. So this is about the INT interrupt. Okay, let's discuss about the polling. So how many ISR do we have for any number of interrupt occurring? Only one ISR, PIC support ISR. So that is only one ISR. Control go to the ISR, instruction gets executed, then it's come back to the place where it was interrupted. Why polling not preferred over interrupt? So here RB0 is what? Switch, isn't it? So I am going to configure this pin as digital keypad. So here, okay, let's discuss along with the code. So here file, open project, polling versus interrupt. So before that I am close this external interrupt code. under the source file we having code. See, so here we using RB0, right, switch. So I am configuring this as source of external input. So here I am going to use two LEDs, LED1 and LED2. So LED1 is for interrupt identifying, LED2 is for digital keypad interface. So if I am constantly reading, that is considered as polling. So here you can see init digital keypad function call, initialization of digital keypad. Now what will happen? Control goes to the digital keypad.c. and it will execute this one. Here you can see global interrupt enable all global interrupts. So here you can see level detection. This is the logic for level detection, and this is set keypad port as input. This one we already discussed, right, in the digital keypad. So here we having one more code, external interrupt.c. See, enable external interrupt and selecting fall edge trigger, and isr.c. Here you can see intf equals to 1, and here we also having header files. So when we press the switch, what will happen in polling? When we press the switch, what will happen in polling? So for example, if switch is pressed, assume if key equals to switch 1, so what will happen? It constantly monitors, right? That's why it is called polling. Switch 1 is pressed. What will happen that time? Both LED turns on, LED1 and LED2. So here we are using two LEDs. So here you can see when key equals to switch 1, it constantly monitors. So when switch 1 is pressed, LED toggling and both LED turns on. Again press LED1 off. So here you can see key equals to read digital keypad. So this is not executed. The control is busy executing for loop in this condition. After this it will go here. Because of polling method, we missed the event. Again press LED1 on. Again missed event. Missing event is the disadvantages of polling, and also a bad response because it is not giving proper output. Here missing event, right? So okay, let's see the output and check. Another disadvantages is there in polling, that is inefficient power management. That will discuss in the next session. Okay, so here you can, let's check the output. File, click file, load hex, then here you need to select polling versus interrupt, distributive, default, production, polling versus interrupt. So here we having two LEDs. When I press RB0, both LEDs turn on. Now again I pressed the switch, right? What happened now? LED 2 turns on and LED 1 turns off. Again, see, again this LED turn off. Again, see, when switch 1 is pressed, both LED turns on. Again press LED 1 off. When press, interrupt generated, isn't it? Again press LED 1 on. Again missed event. See, on, off. So here I am toggling LED 2 and LED 1 for interrupt identifying. So when switch 1 is pressed, both LED on. Again press LED 1 off. Again press, what will happen? Interrupt generated. So because of polling method we missed the event. Again press LED 1 off. Again missed event. That's all about the polling. In the next session we will be discussing about the power management. Thank you all.